Hello everyone, welcome to my channel Upender Math. Today, in this video, we will discuss examples 1, 2, 3 and exercise 7.1 problems of triangles chapter of grade 9 math. Before going to it, please kindly like and subscribe to my channel. Thank you. Let's get into the topic. Example 1 is, in the figure 7.8, OA is equal to OB and OD is equal to OC. Show that, first, triangle AOD is congruent to triangle BOC. Second, AD is parallel to BC. It is given that OA is equal to OB and OD is equal to OC. We have to prove that triangle AOD is congruent to triangle BOC and AD parallel to BC. Let's compare triangle AOD and triangle BOC. OA is equal to OB since it is given. OD is equal to OC since it is given. Angle AOD is equal to angle BOC since they are vertically opposite angles. Therefore, triangle AOD is congruent to triangle BOC by side-angle-side congruency. Let's prove the second one. Triangle AOD is congruent to triangle BOC as we already proved it. So, angle OAD is equal to angle OBC since they are corresponding parts of congruent triangles and they are alternative interior angles. When alternative interior angles are equal, then the lines are parallel. So, AD is parallel to BC. Example 2 is AB is a line segment and line L is its perpendicular bisector. If a point P lies on L, show that P is equidistant from A and B. It is given that line L is perpendicular to AB and AC is equal to BC. We have to prove that AP is equal to BP. Let's compare the triangles PCA and PCB. PC is equal to PC since it is common in both the triangles. Angle PCA is equal to angle PCB. Both are equal to 90 degrees since it is given in the problem that line L is perpendicular bisector of AB. AC is equal to BC since it is given. Therefore, triangle PCA is congruent to triangle PCB by side-angle side congruency. So, AP is equal to BP since they are corresponding parts of congruent triangles. Therefore, the point P is equal distance from the points A and B. Hence proved. Example 3 is line segment AB is parallel to another line segment CD. O is the midpoint of AD. Show that first, triangle AOB is congruent to triangle DOC. Second, O is also the midpoint of BC. It is given that AB is parallel to CD and AO is equal to DO. We have to prove that triangle AOB is congruent to triangle DOC and BO is equal to CO. Let's compare the triangles AOB and DOC. angle OBA is equal to angle OCD, since they are alternative interior angles. Angle AOB is equal to angle DOC, since they are vertically opposite angles. AO is equal to DO, since it is given. Therefore, triangle AOB is congruent to triangle DOC by angle-angle side congruency. BO is equal to CO, since they are corresponding parts of congruent triangles. So, O is the midpoint of BC. Hence proved. Exercise 7.1. First question is, in quadrilateral ACBD, AC is equal to AD and AB bisects angle A. Show that triangle ABC is congruent to triangle ABD. What can you say about BC and BD? It is given that AC is equal to AD and angle CAB is equal to angle DAB. We have to prove that triangle ABC is congruent to triangle ABD. Let's compare the triangles ABC and ABD. AC is equal to AD, since it is given. AB is equal to AB, since it is common in both the triangles. Angle CAB is equal to angle DAB, since it is given that AB bisects angle at vertex A. Therefore, triangle ABC is congruent to triangle ABD by side-angle side congruency rule. So, BC is equal to BD since they are corresponding parts of congruent triangles. Hence proved. The second question is, ABCD is a quadrilateral in which AD is equal to BC and angle DAB is equal to angle CBA. Prove that. First, triangle ABD is congruent to triangle BAC. Second, BD is equal to AC. Third, angle ABD is equal to angle BAC. It is given that AD is equal to BC and angle DAB is equal to angle CBA. We have to prove the first one, triangle ABD is congruent to triangle BAC. Let's compare the triangles ABD and BAC. AD is equal to BC since it is given. Angle DAB is equal to angle CBA since it is also given. AB is equal to AB since it is common in both the triangles. Therefore, triangle ABD is congruent to triangle BAC by side-angle-side congruency rule. Let's prove that second one, that BD is equal to AC. Triangle ABD is congruent to triangle BAC, as we have already proved it. So, BD is equal to AC, since they are corresponding parts of congruent triangles. Now, let's prove the third one, that angle ABD is equal to angle BAC. Triangles ABD and BAC are congruent, as we have already proved it. Therefore, angle ABD is equal to angle BAC, since they are corresponding parts of congruent triangles. The third question is, AD and BC are equal perpendicular to a line segment AB. Show that CD bisects AB. It is given that AD is equal to BC and angle DAB is equal to angle CBA. Both are equal to 90 degrees. We have to prove that OA is equal to OB. Let's compare the triangles OAD and OBC. AD is equal to BC since it is given. Angle OAD is equal to angle OBC. Both are equal to 90 degrees. Angle AOD is equal to angle BOC since they are vertically opposite angles. Therefore, triangle OAD is congruent to triangle OBC by angle-angle side congruency rule. OA is equal to OB since they are corresponding parts of congruent triangles. Hence proved. Now, the fourth question is, L and M are two parallel lines intersected by another pair of parallel lines P and Q. Show that triangle ABC is congruent to triangle CDA. It is given that the lines L and M are parallel and lines P and Q are parallel. We have to prove that triangle ABC is congruent to triangle CDA. Let's compare the triangles ABC and CDA. AC is equal to AC since it is common in both the triangles. Angle ACB is equal to angle CAD, since they are alternative interior angles. Angle CAB is equal to angle ACD, since they are also alternative interior angles. Therefore, triangle ABC is congruent to triangle CDA by angle side angle congruency rule. Hence proved. The fifth question is, line L is bisector of an angle A and B is any point on L. BP and BQ are perpendiculars from B to the arms of angle A. Show that. First, triangle APB is congruent to triangle AQB. Second, BP is equal to BQ or B is equidistant from the arms of angle A. It is given that angle QAB is equal to angle PAB and angle BQA is equal to angle BPA. We have to prove that triangle APB is congruent to triangle AQB. Let's compare the triangles APB and AQB. Angle PAB is equal to angle QAB, since it is given that line L bisects the angle at vertex A. Angle BPA is equal to angle BQA, since both are equal to 90 degrees. AB is equal to AB, since it is common in both the triangles. Therefore, triangle APB is congruent to triangle AQB by angle-angle side congruency rule. Let's prove the second one, that BP is equal to BQ. We have already proved that the triangles APB and AQB are congruent. So, BP is equal to BQ, since they are corresponding parts of congruent triangles. Hence proved. The sixth question is, in the figure 7.21, AC is equal to AE, AB is equal to AD and angle BAD is equal to angle EAC. Show that BC is equal to DE. It is given that AC is equal to AE, AB is equal to AD, and angle BAD is equal to angle EAC. We have to prove that BC is equal to DE. Let's compare the triangle ABC and triangle ADE. AB is equal to AD, since it is given. AC is equal to AE, since it is also given. Angle BAD is equal to angle EAC, since it is given in the problem. Now, add angle DAC on both the sides of the above equation. Angle BAD plus angle DAC is equal to angle EAC plus angle DAC. Angle BAD plus angle DAC will be equal to angle BAC. Angle EAC plus angle DAC will be equal to angle EAD. Therefore, triangle ABC is congruent to triangle ADE by side angle side congruency rule. BC is equal to DE, since they are corresponding parts of congruent triangles. Hence proved. Now, the seventh question is, AB is a line segment and P is its midpoint. D and E are points on the same side of AB such that angle BAD is equal to angle BE and angle EPA is equal to angle DPB. Show that, first, triangle DAP is congruent to triangle EBP. Second, AD is equal to BE. It is given that angle BAD is equal to angle ABE, angle EPA is equal to angle DPB, and AP is equal to BP. We are required to prove that triangle DAP is congruent to triangle EBP and AD is equal to BE. Let's compare the triangles DAP and EBP. AP is equal to BP since it is given. Angle BAD is equal to angle ABE since it is also given in the problem. Angle EPA is equal to angle DPB since it is also given in the problem. Now, add angle EPD on both the sides of the above equation. Angle EPA plus angle EPD is equal to angle DPB plus angle EPD. Angle EPA plus angle EPD will be equal to angle APD, and angle DPB plus angle EPD will be equal to angle BPE. Therefore, triangle DAP is congruent to triangle EBP by angle side angle congruency rule. Therefore, AD is equal to BE, since they are corresponding parts of congruent triangles. Hence proved. Now, the last eighth question is, in right triangle ABC, right angled at C, M is the midpoint of hypotenuse AB. C is joined to M and produced to a point D such that DM is equal to CM. Point D is joined to point B. Show that first, triangle AMC is congruent to triangle BMD. Second, angle DBC is a right angle. Third, triangle DBC is congruent to triangle ACB. Fourth, CM is equal to half of AB. It is given that angle ACB is equal to 90 degrees, AM is equal to BM, and CM is equal to DM. Let's compare the triangles AMC and BMD. AM is equal to BM since it is given. CM is equal to DM since it is also given. Angle AMC is equal to angle DMB since they are vertically opposite angles. Therefore, triangle AMC is congruent to triangle BMD by side angle side congruency rule. Angle MAC is equal to angle MBD since they are corresponding parts of congruent triangles. And also that angle MAC and angle MBD are alternative interior angles. When alternative interior angles are equal, the lines are parallel to each other. So, AC is parallel to DB. As AC is perpendicular to BC, DB also perpendicular to BC. Therefore, angle DBC is equal to 90 degrees. Let's compare the triangles DBC and ACB. DB is equal to AC since they are corresponding parts of congruent triangles. BC is equal to BC since it is common in both the triangles. Angle DBC is equal to angle ACB. Both are equal to 90 degrees. Therefore, triangle DBC is congruent to triangle ACB by side angle side congruency rule. DC is equal to AB since they are corresponding parts of congruent triangles. DC can be written as DM plus CM is equal to AB. We can replace DM with CM as they are equal. It is given in the question. So, 2 times of CM is equal to AB. Send to the right side. We get CM is equal to half of AB. Hence proved. For more interesting math topics, please kindly subscribe to my channel Upender Math. I will be back with one more interesting topic. Till then, bye. Thank you.